Okay, here's a wild thought to kick us off. What if the very expansion of the universe, this constant stretching of space, what if that could be the ultimate fuel for spaceships?
It sounds like pure sci-fi, doesn't it? But, well, that's exactly where we're heading today. It's pretty mind-bending stuff.
Right, harnessing the actual engine of the
Think
cosmos.
about it. Back in 1998, remember those supernova observations?
Yeah.
Exploding stars, yeah, way out there.
Oh yeah, Reeves and those teams.
Exactly. They found something completely unexpected. The universe wasn't just expanding.
Which we already knew, sort of.
Right. But it was speeding up. The expansion was accelerating.
Yeah.
And that pointed to something totally new, something mysterious.
Dark energy.
Dark energy. Bingo.
So yeah, this stuff, this cosmic, whatever it is, makes up, what, nearly 70% of everything? That's our focus today. Our mission, if you will, is to explore this potentially revolutionary idea. Can we actually tap into that expansion, ride the space-time waves?
It's a huge question.
We've got some great source material, a podcast discussion, key research papers that really get you thinking about technologies that could just rewrite space travel completely. So yeah, get ready for some cosmic aha moments, hopefully.
Okay, let's dive in. Dark energy. What is it, fundamentally?
It's like anti-gravity on a huge scale, right?
Pretty much it's a repulsive force. Those supernova results were key because they showed gravity wasn't, winning. It wasn't slowing things down like everyone assumed it would after the Big Bang.
Everyone thought big explosion, things fly out, gravity eventually pulls them back or slows them down.
Exactly. But nope, something else is pushing things apart faster and faster.
And it's weird stuff. The properties are just odd.
Definitely odd. For one thing, it seems to be everywhere, right? Spread out incredibly evenly. No clumps.
Just this constant presence. And it acts like negative pressure. That part always gets me.
Yeah, that's super counterintuitive. Instead of pressure pushing in, like you'd expect.
It pushes out. It stretches space itself.
Precisely. And in Einstein's theories, this connects to the cosmological constant, lambda. Remember that?
The thing Einstein supposedly called his biggest blunder, but now it's back.
Sort of, yeah. It represents this kind of baseline energy density of empty space itself. And it fits the behavior of dark energy pretty well. It's a key part of the current model.
Okay. And really important, this is not dark matter. People mix those up all the time.
Oh, absolutely crucial distinction. They're both invisible, both mysterious, but totally different jobs.
Dark matter pulls things together with gravity, holds galaxies in one piece.
You got it. The cosmic glue. Dark energy, though, it's the opposite. It's pushing those galaxies, those clusters, further and further apart.
Okay, I like the analogy sometimes used, the raisin bread.
Ah, yes, the rising dough.
Right, so the dough is space, the raisins are galaxies. As the dough bakes and rises,
The dough expands everywhere,
and the raisins all get further apart from each other. Not because they're moving through the dough.
but because the dough itself is stretching between them.
Exactly. That's kind of like dark energy expanding space, carrying galaxies along for the ride.
It's a good visual. Helps wrap your head around it.
So, okay, if space itself is expanding, the next leap is, well, can we use that? Can we somehow ride that expansion?
And that's where things get really speculative, but also really exciting. Could you convert that fundamental stretching into propulsion?
Ditch the rockets, surf the cosmos.
Essentially, yeah. Instead of carrying fuel, you're using the fabric of space-time itself.
So how would that even work? Theoretically, I mean, there are a couple of big ideas floating around, right?
Right. Two main theoretical avenues people are exploring. First, there's this concept called differential expansion drives.
Okay.
The name E-Lens comes up here from a 2021 paper. The basic idea is, could you make space contract in front of your ship and expand behind it?
Hang on, that sounds a lot like the Alcubierre warpdrive idea.
It does bear resemblance.
Yeah.
It's manipulating space-time locally. But the key difference, or at least the hope in Lenz's work, is that maybe, just maybe, you could achieve this using classical energy fields, positive energy, not the weird exotic matter the original Alcubierre drive needed.
Oh, okay, so like a warp bubble, but maybe without the impossible ingredients.
That's the hope, yeah. Still highly theoretical, of course.
And the other idea, you mentioned too.
Right. The second one is sometimes called void propulsion.
Void propulsion, like using the empty bits of space.
Kind of. See, the universe isn't perfectly smooth. You have these enormous cosmic voids regions with way less matter, fewer galaxies.
Okay.
The idea is maybe the density of dark energy itself isn't perfectly uniform either. Maybe it varies slightly between these voids in the denser regions.
So you could surf the differences?
Potentially. A
Hmm.
starship might be able to navigate these regions using the gradients, the differences in dark energy density or space-time expansion, to get a push. A bit like a gravitational slingshot around a planet.
But using space-time itself instead of gravity wells.
Exactly. Exploiting the large-scale structure of the cosmos.
Which, okay, you mentioned it earlier, this all inevitably brings us back to the classic sci-fi dream, the warp drive, the Alcubierre drive.
It's hard not to make the connection, yeah. Miguel Alcubierre back in '94.
Can you quickly remind us how that was supposed to work?
Sure. So the Alcubierre concept is about faster than light travel, FTL, but without breaking the local speed limit of light.
The ultimate loophole.
That's the idea. You create a bubble of space-time around your ship. You then make space-time contract sharply in front of the bubble and expand rapidly behind it.
So the ship inside the bubble isn't technically moving faster than light locally.
Right. Inside the bubble, space-time is flat. But the bubble itself gets pushed along by this space-time distortion, potentially moving faster than light relative to everything outside the bubble.
Okay, but there was always that massive catch, wasn't there? The showstopper.
Oh, yeah. The big one. Exotic matter.
Right. Stuff with negative mass or negative energy density.
Exactly. The original calculation showed you needed this hypothetical stuff with properties, well, unlike anything we know exists or even could exist, according to current physics. Negative mass energy density. Just not something we've ever seen.
So it was a cool idea, but seemed impossible based on known physics.
Pretty much. It seemed like a dead end for a long time because of that requirement.
But now, you're saying newer ideas like lenses work, maybe offer a way around that, connecting back to dark energy.
Well, that's the intriguing part. By playing with different geometries of spacetime, different field configurations, some recent theoretical work, including lenses, suggests you might be able to create similar warp-like effects using only positive energy. Perhaps by manipulating fields that share some properties with dark energy, like that negative pressure aspect.
So dark energy, or something like it, could be the key to making warp drive, or at least space-time manipulation, feasible without needing unobtainium.
It's a potential link, yeah. It's bridging the gap between these abstract warp drive concepts and the actual physics of dark energy that we observe. Still a huge theoretical leap, mind you.
Okay, so these are fascinating theories. But is there anything at all in the real world, experiments or observations that even hints this isn't pure fantasy? Any tiny hooks in reality?
Well, hints might be generous, but there are phenomena that touch on related concepts.
Like what?
Okay, so there's the Casimir effect, where two plates placed very close together in a vacuum experience a force pushing them together.
Yeah, I've heard of that. Quantum vacuum weirdness.
Exactly. It comes from quantum fluctuations in empty space, virtual particles popping in and out of existence. And crucially, it demonstrates that the vacuum can exert a kind of negative pressure, which is reminiscent of dark energy's behavior.
Okay, so empty space isn't entirely empty or inert?
Right. And then there's the whole field of quantum field theory in curved spacetime. It's complex stuff, but it basically suggests the energy of the vacuum, the energy of spacetime itself, isn't necessarily fixed. Under extreme conditions, maybe near black holes or in the very early universe, it might be possible, theoretically, to extract energy from it.
What about actual experiments trying to find new propulsion? Wasn't there that NASA EagleWorks thing, the EM drive?
Ah, yes, the EM drive. That generated a lot of buzz and a lot of controversy.
Because it seemed to produce thrust without shooting anything out the back, violating conservation of momentum.
That was the claim, yeah, a propellantless drive. Now, the experimental results were really difficult to replicate, very tiny effects, possibly experimental error. Most physicists remain highly skeptical.
So probably not a warp drive precursor.
Probably not. But it shows people are actively looking for ways to push beyond standard rockets, exploring the boundaries, even if those particular experiments were inconclusive. It keeps the question alive. Are there propulsion principles we're missing?
Okay. And looking outwards, at the cosmos itself. Any clues there? You mentioned voids earlier.
Right. This is more observational speculation, but some things are interesting. The way large galaxy clusters seem to be moving in bulk, sometimes called dark flow, doesn't perfectly align with predictions based only on the distribution of visible matter and dark matter.
Suggesting something else is pushing or pulling.
Possibly. Or the dynamics within those huge cosmic voids we talked about. Some researchers wonder if these observations might hint at subtle variations or gradients in dark energy across vast cosmic distances.
So natural variations in the expansion rate.
Maybe. If such gradients exist, and if we could understand them, well, that connects back to that idea of void propulsion. Maybe nature has already created pathways or regions that could, in the very distant future, be exploited.
Okay, let's pull back a bit. If, and it's a huge if, but if we could actually crack this dark energy propulsion thing, the implications are just staggering.
Oh, completely transformative. Think about that line from the source material we looked at. Fuel isn't something we carry, it's something we live in.
Yeah, that really stuck with me. Fuel is everywhere.
Imagine. No more hauling massive tanks of propellant, the sheer weight saving, the complexity reduction. It changes everything.
Interstellar travel suddenly seems less impossible.
It makes it conceivable in a way that rockets just don't, realistically. Journeys that would take millennia might become, well, still long, but potentially achievable within human lifetimes or generations.
Right.
That's the kind of aha moment this unlocks. The universe itself becomes the fuel tank.
You start picturing starships sipping energy from space-time itself, maybe even colonies using manipulated dark energy somehow, stabilizing habitats.
Who knows? And that term that came up, cosmodynamics.
Right. Engineering the universe itself.
A whole new field based on manipulating the shape, the expansion, the very fabric of space-time as a resource.
Yeah.
It's almost hard to imagine.
Okay. Deep breaths. We're getting way out there. Let's talk feasibility. This sounds amazing, but
Yeah.
how likely is any of this?
Right. Time for a reality check. While the theories are fun to explore, a working dark energy engine, we're talking probably centuries away, if ever. The hurdles are immense.
So what are the biggest ones? Where do we even start?
Well, first, our fundamental understanding of dark energy is still pretty basic. Is it the cosmological constant? Is it something else? Something dynamic? We just don't know for sure. We need a much better theory.
Before we can even think about engineering it.
Exactly. Then, assuming we understand it, how do you actually harness it? We're talking about an effect that's incredibly diffuse, spread over cosmic scales.
Yeah.
How do you concentrate or manipulate that energy density enough to get useful thrust for a spacecraft?
It's like trying to build a dam to harness the tide across the entire Pacific Ocean.
Something like that, yeah. And then you have the really thorny physics problems. Causality violations, for instance. If you start messing with space-time too much, especially for faster-than-light travel, you risk creating scenarios where effects happen before their causes. Paradoxes.
Raking time.
Potentially, yeah. We need to ensure any propulsion system respects fundamental physics, or our understanding needs a major overhaul, creating stable, controllable warp zones, if that's the route. Hugely challenging.
And just steering. If space is expanding everywhere, how do you even navigate?
Another great question. If you're expanding space behind you and detracting it in front, how do you turn? How do you stop? These are engineering problems on a scale we can barely conceive of right now.
So, yeah, decades, centuries.
Yeah.
Maybe never, but it's fascinating to think about.
It absolutely is.
Okay, so as we wrap up this deep dive, wow, we've gone from that surprise discovery in '98, the accelerating universe,
Yeah, the initial shock.
to exploring what dark energy actually is, differentiating it from dark matter.
The raisin bread analogy.
Right. Then into these really wild propulsion ideas, differential expansion, void propulsion, the connections to warp drives.
And the potential ways around that pesky exotic matter problem.
We touched on hints in real physics, like the Casimir effect, and even cosmic observations. And then the truly mind-bending implications fuel everywhere, cosmodynamics.
And finally, the sobering reality check about the enormous challenges.
It really leaves you with a big question, doesn't it?
It does, this dark energy. Is it just this fundamental property of the universe, something that dictates its ultimate fate, pushing everything apart forever, a limitation? Or is it an untapped resource? Is it a cosmic ocean of energy, a means of propulsion, just waiting for a civilization, maybe ours, maybe some future one, to figure out how to actually use it?
It makes you wonder what understanding we might unlock down the line.
Absolutely. It's a lot to chew on.
Definitely. And hey, if this conversation got your own mental gears turning, seriously, look up some of those papers we mentioned. Aris on the supernovae, Alcubierre on the warp drive, Lentz's more recent work.
Yeah, dive deeper if you're curious. It's a fascinating territory.
It really shows how much we still don't know, and maybe, just maybe, what might be possible someday. The universe still has plenty of secrets.